Hello, good morning everyone. My name is Devasilan, son of Muttarasan. My metric ID is HA19029 and today I am going to present about my project. My project objectives are to develop simple IoT system which should be able to take data from ultrasonic sensor and store the data at MySQL database. We use different kind of sensors, but I choose ultrasonic sensor, and I need to set up on and off control system using a web page design. And I also use to create a system which can show the historical data in form of charts and graphs. This is the master's task. And these are my list of components. First, my node MCU and the ultrasonic sensor, and the last one is jumper wires. And here is my electronic system circuit diagram. My VCC port from ultrasonic sensor is connected to 3 volt. My trick port is connected to D0. My echo port is connected to D1, and my ground is connected to ground. And basically this is my web server interface where it have on off button and system status where the data collecting is off or on can be seen, and also I have a link where it will redirect to my SQL database. And this is my flowchart. uh, Start, if Wi-Fi or hotspots available, so we wait for requests. If okay, then proceed, and we obtain the IP address. Once we obtain IP address, we can copy and paste in the Google Chrome, and I can access to my web page design, and the data is stored at MySQL database. If no, we have to activate the sensor and also the node MCU back, and after that the user receives the data, and lastly all the data is shown in DB show, which is my MySQL database. And this is my ASP web programming code, and this is my all the includes the libraries, and this is the string temp value and the hotspot ID and password. I use my laptop as a hotspot device, and this is the coding for the web page design. And these are my calculation for the ultrasonic sensor to measure the distance. Okay, this is my web page design where I customized my uh, design of the web. And this is my DB insert, which is used to obtain the reading, the ultrasonic sensor reading, and also helps to store the data in MySQL page. And this is my MySQL database looks like. My database name is ESP Sonic, and this table is a Sonic table. It shows date, time, and also the sensor value. I have more or less 31 to 32 rows. I record for nearly 2 days. And this is my DB visual. This is the MySQL database. It updates time to time. And this is my DB show. This coding is used to show the this is used to show the data in my MySQL database. And for the ultrasonic sensor, there are some precautions for surrounding environment. The first one is the sensing distance of the ultrasonic sensors will decrease if there is any water drops on the surface of the emitter or receiver. And the reflective model may not detect any objects if there is any objects absorbing sound such as powder and cotton on the surface of the emitter or receiver. The ultrasonic sensors cannot be used in a vacuum or explosion-proof area. And lastly, we cannot use the ultrasonic sensor in vaporous place because non-uniform steams cause difference in temperature and therefore measurement errors can be seen. As a conclusion, I learned how to develop a simple IoT system using ultrasonic sensor which can store in MySQL database. I was able to create a web-based page where I can control the system on off button. From this course, I really learned a lot and I hope I could apply those in the future. And now I'm going to show my demonstration. Okay, this is my Arduino coding. I'm uploading the data. Okay, the data have been uploaded. And if I click the serial monitor, I can obtain the IP address. I copy the IP address and paste it here, and I can view my web server. And if I click on, the data start to collect. Data collecting is running. And when I click off, the data collecting is stopped. And here's the link to my MySQL database. When I click this, it will redirect to the MySQL database where all the data is stored. And if I refresh, I can see all the data like 2 days till now. And basically that's my demonstration, and thank you.
Good morning everyone. Okay, now I'm going to do my project presentation for the PHP project. My role is as a slave, and our task is to develop a simple IoT system that is capable of taking data from a sensor and storing it into a MySQL database, and to be able to control the sensor through a web page. Okay. Okay, the components that I use for my project is a Node MCU, vibration sensor, USB cable, and jumper wires. And this is my circuit diagram. My output is connected to D2 ground, and this is power supply. And this is my flow chart. When I start, I'll check if the Node MCU is connected. If it is connected, then it is automatically connected to the server. If not, I'll reset the Node MCU. Click on to collect data, and then off to stop collecting. And then finally, if I want to view collected data, I'll go to DB show, If not, after that, N. Okay, this is my Arduino code. Okay, and then okay, this is the code. Integer system status. This is all for the buttons. Uh, to collect data, to stop collecting. Uh, this is to send my vibration value to the server. Void setup. My SSID and password. So if when my node MCU is connected, it will show connected to my. It will show the IP address, and then at the bottom it will read HTTP server started. Okay, this is my DB insert code to insert the collected data into my SQL database. Every time the data is connected successfully, it will read successful. If not, it will come out as error. And then this is my DB show to show the collected data in a table form. And then this is my web page design code. And this is how my web page looks. On off button to control to switch on and off the node MCU, and then my SQL database, the link hyperlink to view collected data. Okay, next I'll show you guys the demo. This is my Arduino code. Okay. Can you guys see my Arduino code?
Yeah.
Can I?
Yeah. Yeah.
Okay. Okay, my code is uploaded. My okay, this serial monitor. Uh, right now it's not connected, so I'll reset. I'll reset my node MCU, and then it's connected. My server is connected to my server. Uh, After I copy paste, it will be this. You see, 137203. I'll show you guys. Okay. When I click on, data collection is running. So every time my data is successfully collected, it will read successful. And the delay I have set is 5 seconds. And okay, then I'll press off. It will read data collecting is stopped. If I want to view my database, this is it. I refresh. This is the current data that we took right now, 4:25 p.m. It is 1 because there is no vibration. When it has vibration, then it will be all these values. So the problem I found during this using this vibration sensor is that the sensor is not very sensitive. As you can see, the values that I get, they are all different range, some hundreds, some thousands, and then 10,000s. So it's not very sensitive to just leave it on top of something and then just leave it vibrate. I need to actually uh, hang something that vibrates so that it reads. So I think that would be all. So thank you.
I would like to present about my part, the IR sensor. My name is Peter Lewis, and I am a I did the IR sensor part for this part. The components the need for my system is the ECRT 5000 IR reflective sensor and the Node MCU. These are the components that are needed to create the system. Uh, the The IR sensor is made up of a transistor and an infrared LED, and this sensor has a coating on it that helps reduce the chance of environmental interference by filtering out light that isn't in the infrared spectrum, and that's what gives it the input side, the black color. Uh, it This sensor is mainly used to detect the presence of a physical object, such as a coin in a coin sorting machine. On a black to white scale, it may also be used to determine the color of something. A line following robot can use this concept. The amount of reflected infrared light varies depending on the shade. Other than this, it can also be used to detect rain or liquid leakage. The way it is it works by emitting infrared light from the LED and registering any reflected light on its phototransistor. It changes the current flow between its emitter and collector according to the amount of light it receives. This is the circuit diagram. The analog output is connected to the AO of the node MCU. The ground is connected to the G, and the VCC is connected to the 3 volts of the node MCU, and the digital output, the DO, is connected to the D6. This is the flow chart. When the node MCU, when this system starts, the program starts, it will connect the node MCU, and if it is connected, it will connect to the server. If not, the node MCU is resetted and go straight to connect it to the server. Afterwards, the UI layout can be accessed, and in that layout, you can click the on button, then the data will be collected. And then the data that has been collected is then stored into the server. Afterwards, the button can be clicked, the data collection can be clicked off, and then the collection will be clicked off. It is the user is able to view the data stored inside the database, uh, and if they would like to, they could see the data shown. If not, the program ends. This is the block diagram where the node MCU, I mean the sensor is connected to the node MCU, which is then connected to the laptop as a power source, and the laptop hotspot is connected to the node MCU, then straight to the web page, and then connected to the database, MySQL database. This is the setup. This is how it should look like with the sensor module, the node MCU, the USB, and the wires. This is the Arduino code. Uh, as you can see, there's the embedded HTML code inside the code. This is the web page uh, of this UI layout, and this is the rest of it. Next is how this code would detect, detection is that by the when the sensor receives that it will I mean the data received by the sensor will show a number from a number less than 1000 and more equal to 1000. So when the number sent by the sensor is less than 1000, the code here will be received as that the sensor has detected a physical object or something. If not, it will detect nothing. Afterwards, all of those information is then stored into the server. This is uh, the database insert code where the Arduino would access the database. and this is the uh, database show code where this would store the uh, store and show the data inside a table. This is what the web page would look like. As you can see, there's the two buttons and the database show PHP is linked to the go to MySQL database. This is what the data collected would look like. This on the left is the table of the database show, and on the right is the MySQL database. Uh, Now I would like to show the demo. Let's see. Um, Now I'm going to connect the Node MCU to the a moment. Yeah, I'm going to connect the Node MCU to uh, the computer, and it should start now. Okay, it has started. Oh, this is the web page. As you can see, when I click this button, it will turn on and it will show that the data is collecting. Wait, a moment. I will re-upload the code. Okay, it has done uploading, and now you can see it has reconnected, and I will copy this again. Okay, turn it on, and now it has connected. Now the sensor will detect physical object. So as you can see, it will connect on my hand, and also it will detect. But when it's not connected, it doesn't sense anything. It will not detect anything. Now when I stop this data collection, it will stop the data collection, and now you can see the data collected here. Most recent one will be this one. Here it has detected twice, not detected anything twice, and detected once here. As you can see here, it's also shown in the database right here. Okay, that's all from me. Thank you.
Hello, I am Shalin and my ID number is HA19018. And as a group member of Group Sensor, I am assigned to work as a slave and in order to develop a simple IoT by collecting data from rain sensor and interfacing it with Node MCU and store them into my SQL database. To start off, how do we define the rain sensor? Rain sensor is a tool that used for rain detection. It consists of two components, which are sensing pad and the control module. So sensing pad is a series of exposed copper traces that are placed in the open, possibly over a roof or in a location where rain can affect them. These traces are not usually connected, but they are connected by water. In this case, I place the sensing pad by my open window as it is the nearest to my laptop. Um, Control module. It includes an electronic module that connects the sensing pad to the Node MCU. The module generates an output voltage based on the resistance of the sensing pad, which is available via an analog output pin. The same signal is fed into an LM393 high precision comparator, which digitizes it and makes it available via an digital output. The module includes a potentiometer for adjusting the sensitivity of the digital output. Using a potentiometer, we can set the threshold so that when the amount of water exceeds the threshold value, the module outputs low, otherwise high. So the blue one is the potentiometer where we can adjust the sensitivity of the rain contact and produce a digital output. And beside it is the black one, and it is the LM393 comparator. The Node MCU is a microcontroller unit, which is an open source firmware and development kit that can be used to prototype or build the IoT products. It includes firmware that runs on expressive system, ESP8266 Wi-Fi, and hardware that is based on the ESP12 module. The language used is the LUA scripting language. Next will be the jumper wires that are used in this project. We use 5 female-to-female jumper wires. And it is compulsory that we use micro USB cable to connect to the MCU, not MCU to the laptop. So how does it work? The sensing pad, which is made up of a series of exposed copper traces, acts as a variable resistor, similar to the potentiometer, whose resistance varies depending on the amount of water on its surface. And this resistance is proportional to the amount of the water present. When the amount of water increases in the surface of the sensing pad, the better the conductivity. Thus, the resistance is lower. When the amount of the water on the sensing pad is low, the conductivity is lower, and thus the resistance is higher. The sensor generates an output voltage based on the resistance, which we can use to measure to determine whether or not it is running. This is my setup and the total component that I use, which are 5 jumper wires, a sensing pad, control module, a node MCU, and a micro USB. And here is how my electrical circuit diagram looks like. And to have a closer look, These are the pin connection between the rain sensor and the node MCU. Two pins of the sensing pad is connected to the rain control module. The analog output of the module is connected to the analog output of the node MCU. The digital output is connected to ground, and the VCC is connected to the in of the node MCU. And this is the block diagram. The node MCU is connected to laptop, and the rain sensor is connected to node MCU. After the data is collected, it will be displayed in the database MySQL. And we can control the data collecting by switching on and off. And here is the flowchart. At the start, the node MCU is connected to the laptop, and when it is connected, it will be connected to the server. If it does not connect, we should reset the node MCU, and this will lead us to the server. And after that, we go to the user interface web page and click on. The data will start collecting. If it is raining, the node MCU LED will light up. Otherwise, it will not light up. So after a certain period of time, we can click off to stop the data collecting of the rain data to be stored in the server. And after that, we can view the data. If not, the process will just end like that. This is my Arduino code. Here is the Wi-Fi settings, which I use to connect to my mobile smartphone Wi-Fi hotspot. And this is the code for my web page user interface. And here is the system status and the code for the data collection. And this is the declaration for the rain value. And this is my how it collects the rain data. When the data is when the sensor value detects 20, more than 20 or equal to 20, it will receive as detected, where otherwise it will be not detected. And this is the code for sending the data to the server. This is the declaration of the pin output for the LED. Yeah. This is my DB insert code. And this is the DB show code for displaying the data in a table form. And here is how my user interface web page looks like. Here we can control the system by switching on and off. When the data collected, it will store the data inside the MySQL database. And below here is the system status. Here is the example of data collected in the database. And now is the demonstration. So here it shows that it has been successfully connected to the laptop. And in order to start collecting the data, we go to the IP address shown here and paste it on the browser. And we can start collecting the data by clicking this on. And now it is showing that the data is start collecting. and it says that rain is not detected because it is currently not raining. And after a certain period of time, you can stop the collecting by switching this off. And it will show that data collecting is stopped. When we go here to the database, you can see that this is the data collected in the form of table with date, time, and the status present. And this is the recent one that I've just taken just now. You can also see the data here in the table, rain table. And this is the recent data that I just taken. And it has over 200 pages because I've been collecting data for 2 days. For this project, the only problem that I encountered is that the USB, my USB, sometimes it does not recognize whether my laptop, so it is hard to connect the MCU to the laptop. And for the rain sensor, I have no problem with it. That's all from me. Thank you.
My name is Muhammad Adnan bin Muhammad Zaini. ID number HA19002 as member of Group Censored. My task is, my role is as a master. My objective is to make sure the web page successfully running in a local network, to make sure the data can be retrieved to show in chart. All draft are designed to suit this kind of data, and the design of web page are user-friendly and creative. So the computation freedom for my part is HTML, which is to create the web page, CSS to styling the web page, PHP to collect the data to the database, JavaScript to draw the chart. So here is my chart. I start and by getting the data from the slash member, and then I will import the data to my PHP database, and then create our web page, and then extract the data from the database to the web page, and lastly the chart is displayed in the web page. So here's my localhost web file. Index for the web page, the start for the styling web page, and the others for the chart. So here is the web page file, which I named as index.php. So I use Bootstrap and also source from font system for the font. Here is the header section where I put the group member's name. So here is the data where I present the chart, the first division, ultrasonic sensor, second eye sensor, followed by the others. So it will jump to the TP date chart ultra to show the chart, to present the chart. Here is style.cs file for the styling web page, where I for the color, over the header, enter the division and to change the font and also do the some padding and also margin to make it more styling. So here's the output. Page interface. So here is uh, the face for the chart. The first one is for the ultrasonic chart. So it's the best. So when the to collect the data from the server, it will go to the ultra DHP. Yeah, and you collect the data from the database. And here is the output. So actually, when we put the mouse here, it will show the detail. And also, it will show the detail like date and the value. So here is the graph for ultrasonic sensor value and date. And the next one is for the time. So same. We go to ultra time HP to collect the data from the database. Here is just for the HTML interface. Yeah. We will collect the time from the database. It's a value and order it by ascending actually. Ascending order. So here is the output. Next, for the pie chart. Same. We collect the data from the database. ESPIR. So for the IR sensor, actually from the detection, it only have two types. It's not a value, but a type, which is detect and not detect. So I need to select the detection, count its number from detectable table and group it by two different type of data. So it will represent like this: detect and non-detect. Conclusion, so the WordPress is successfully running in our network. The data can be retrieved to show in chart. All graphs are designed well to this kind of data. And the design of which are user-friendly and intuitive. So now I will show the demonstration. So example, so here is the data from the bricks and canvas. I will do the select table. So the database is ESP Sonic. Sonic. Create. So then I click import. This file. And enable. So actually when I find this kind of data, I need to add some more, which is ID. Also Sonic. So at first, there's no value, there's no output. And just now I have just import the data to the SQL database. And when I click refresh, the data is shown. Then goes to the pie chart. For example, the table. This is SIR. SIR. So the data is available here. For the workforces. Okay. Yeah. Here is my WordPress interface. I also add hover effect, and when the mouse is here, the color is changed to the black. That's all for me. Thank you.